Welcome to this study of salient pole synchronous machines, and in this salient pole synchronous machine similarly can be operated both as motor and generator mode. In case of motor mode, and phasor diagram is very important in synchronous machines. In case of cylindrical synchronous machine, we drew the equivalent circuit EF, ZS and terminal voltage. In salient pole synchronous machine, it is not done. It is difficult to obtain some equivalent circuit of that sort because of the presence of two reactances, synchronous reactances. So, one is along d axis, these are the key words in XD and XQ. What is XD? XD is its armature reaction reactance plus XL, XQ is XARQ plus XL. Anyway, this we have discussed. So, and XD will be much higher than XQ, and RA sometimes is neglected. Also, we know how to draw, take into account the effect of RA. Okay. So, this is the thing, and in our last classes we found out the we were trained to draw the phasor diagram correctly. That is, essentially you have to determine Q, what to draw in the phasor diagram. I must be provided with this information that motor is, tell me motor is operating either in generator mode or motor mode. That is one information. Whether that generator is operating at lagging power factor and how much current it is supplying. So, I A, theta and terminal voltage will be known, and then you can draw the phasor diagram. In case of generator, E f is equal to V plus I A R A plus J I D X D plus J I Q X Q. Since I D I Q are different, so they cannot be put in a single circuit and say that X D X Q in series or they are in parallel. No, it is not possible. Separately you have to do. In case of generator mode, this point must be very carefully handled, that is V is equal to I A R A plus J I D X D plus J I Q X Q, and I D I Q will be different because armature current is broken up into diff. So, they cannot be represented in series or in parallel, no. So, the important point is from the knowledge of V, I A, theta, get delta, and then generator mode, V is there, delta will E f will be above it, which will be along q axis, then draw d axis, then I A theta is known, break it up, I D I Q, go on adding these drops, you will correctly land up with the phasor diagram. And we have extensively discussed about this. Now, today another important thing I will do, that is called the expression for power, expression for power. Like in cylindrical machine, we found that the real power was equal to E f V by x s sin delta, where delta is the angle. So, similar expression we will try to derive for a salient pole machine. And in this expression, recall R A was assumed to be 0, and of course, I could take R A into account, another term will come, and the essential for deriving this type of equation started, we started with the fact that V I A star we did, and we got the, in one stroke we can obtain the expression for both real power kilowatt and the reactive power, how much the machine is handling. So, first what we will do is this expression for power, a salient pole generator, say delivering lagging power factor current, delivering IA at lagging power factor. What is the expression of S? Both real and reactive can be found out. Okay. So, we will start and we will first find out per phase power, then at the end we will multiply with 3 to get the total power expression or torque. Because the moment you get power expression, you can easily find out torque, because speed is constant. So, in synchronous watt the torque is also derived in one stroke. Let us see. So, I will say that S, so it is a generator at a terminal per phase, it is delivering a current I A, that is the thing. So, S will be V I A star per phase, this is the thing. But we know that, or I will draw the phasor diagram, it will be, so this is the starting point and rest of the things are routine works, except that you have to draw the phasor diagram. With R A equal to 0, you start with V, you draw I A, you know theta, then delta is known, tan delta expression, and I will draw then q axis and I will draw then d axis. Then I will break up this as I d and I q, and this is delta, tan delta is known. And then if R A is neglected, R A is 0, then E f, this is true, is equal to V plus j I d x d plus j I q x q. So, V plus I d x d, it will be like this. This is j I d x d, and you know to this you add this one j I q x q, and this length will be your E f. Okay, and this whole angle is also psi, and this is psi. We have got this. Now, this voltage phasor V, it can be written as, this voltage can be also thought of consisting of this and this, is not, and this is V d and this is V q. V d is V sin delta and V q is V sin delta. What I am telling is, this V can be written as V d plus j V q. What else? This phasor plus this phasor. Similarly, I A can be written as vector ID phasor plus j I q. What else? Now, power, I am planning to do this operation V I A star. Therefore, I A is this. So, I A star complex conjugate will be I D minus j I q, is not? This will be the thing. Then I have to multiply these two to get power. So, let us multiply. So, voltage is V D plus j V q and complex conjugate of the current is I D minus j I q. So, open the brackets, so that I am sorry, this I must write S, total complex power, and this will be equal to real part. So, V D into I D, and there will be another this j V q I q, j j minus 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 plus. So, this will be V q I q, is not, and then the imaginary part will be plus j V q I D, this and this, and minus j V D I q. Now, V D and I D are in same phase. Therefore, it will be simply multiplication of V D and into I D. V q I q in same phase, it will be this one V q I q, is not, and then plus. So, this is the thing, plus j whatever it is here V q I D minus V D I q. This will be the thing, and this will be only magnitudes, this will be magnitudes V q into I D and this one. Now, the question is that I mean what I am trying to tell, that once you get this expression, this will give you the real power and this part will give you the reactive power Q. If I simplify these expressions, and from that I will get the expression of power delivered to the bus or to the load by the salient pole synchronous generator. So, I have assumed generator mode of operation, lagging power factor. Is that clear? So, that is the thing. Now, therefore, real power delivered is P, is nothing but V D I D plus V Q I Q, that is all. Now, recall the V D value is nothing but V sin delta and V Q is V, oh my god, this is V T sin delta and V Q is V cos delta, correct that, V Q is cos delta, V cos delta, V sin delta. So, I will put those values. So, I will write this to be V D is equal to V sin delta into I D plus V Q is V cos delta into I Q. What is my target? My target is to get an expression of power in terms of excitation voltage, terminal voltage and load angle and x d x q, etc. So, that is the target, but here you know unfortunately ID is present, IQ is present. So, I must express this ID, IQ in terms of IA, XD, XQ, etc. So, how this can be done? It is very simple. You see this length V d is equal to V sin delta, mind you this is R A equal to 0 case. So, V sin delta will be nothing but IQ into XQ, this length and this lengths are equal. So, note that V sin delta is equal to nothing but IQ into XQ, is not, that is there, and V cos delta is equal to EF minus this length, this total thing is magnitude of EF minus IDXD. So, V cos delta is EF minus of IDXD. This will be the thing. So, we have to put the value of IQ and ID from these two expressions here. So, let us do that. So, V sin delta ID I will write from this, I will write it is equal to V cos delta, oh sorry, ID is equal to EF minus V cos delta divided by XD, and IQ from this I will write IQ is equal to V sin delta by XQ. These are the substitution I have to do to get rid of ID and IQ. Okay. So, V sin delta into ID, that will be equal to EF minus V cos delta divided by XD plus V cos delta into IQ, and what is IQ? IQ is V sin delta by XQ, that is all. So, now in the right hand side everything is known. How do I know delta? Because I know at what power factor it is operating, which mode it is operating, this that we discussed so much. EF is known, excitation voltage, XD, XQ are known, B terminal voltage is of course known, bus voltage. So, this is the thing. Now, this if you simplify, you will get the first term, that is this will give is EF V by XD into sin delta. Put it inside, you will get this. Then the second term from this fellow will be V square sin delta cos delta by XD, and this term will be simply V square by XQ, once again sin delta cos delta, it will be like this. Now, this one is do not disturb it, I have already got it sin delta, nice form. Then these two you divide by 2, multiply by 2, so that it will become V square by 2 and then 1 by x q, this minus 1 by x d into sine of 2 delta, and this is the expression for power. you have to multiply with 3 to get the total power. So, this is the expression we are looking for. So, this is the real power expression. If I wish, I can also calculate how much reactive power it is delivering by calculating this, put the value of V q, I d, and you can get the expression for q, which I am not doing, because I will concentrate on this, it tells you many things. Recall that, so we have got the power as E f V by x d sin delta minus V square, not minus, plus, this is can be written also in this form, x d minus x q by x q x d x q into sin 2 delta. This compare power expression, power or torque, this is synonymous with torque, because so compare power expression of a non-salient pole synchronous generator. How it looked like? It was P is equal to per phase E f V, these are all phase voltages, by x s sin delta. So, first thing you note is that in case of salient pole machines, there are two terms, one is sin delta, another is sin 2 delta. So, in this case the P delta curve looked like this. This is 0, this is pi. Maximum value of delta for stable operating point is pi by 2, that is all. In case of this, it will be, if you sketch it, it will have two terms. So, one is this term and another is a sine term. It is 2 delta, therefore, one complete cycle will be present between 0 to pi. This is pi by 2. This will be the, and these two if you add point by point, you will get the expression for power or torque on the y axis. Okay. Now, the question is, what is this maximum value? This maximum value depends upon E f V by x d. And what is this maximum value of the sin 2 delta terms? It will be V square by 2 into x d minus x q by x d x q, is not? This will be the maximum value. Now, recall one thing, that this is the expression of a salient pole machine. If I say in a machine x d equal to x q, what does it mean? It means it is a cylindrical machine. There is no difference between direct axis and quadrature axis reactances, and this term will become vanish and only sin delta terms will be present if x d is equal to x q. However, in a salient pole machine, x d is not equal to x q. There will be difference, but not much difference, there will be difference, and V is the terminal voltage. This is a large number, no doubt. Here also E f V by x d is a large number, but this factor is not so large a number, difference of x d and x q. That is how much salient the pole configuration is will decide what is this peak value. Maybe 10-15% of this little, but anyway this will be the thing. So, and if you add these two point by point, so peak will not occur here. This curve will be somewhere here. This curve, if you add, roughly I am drawing, it will be somewhat skew sort of thing, it will be there, and it must pass through this point, because this plus this is this, and it will become something like this. This is the sum, that is the total power will be that red curve. You see the stable region will then occur slightly below this one. You cannot go up to 90 degree, before that maximum operating point will be decided by these things. Where is this load demand you get, and this will be the operating delta of the synchronous machine. But one interesting thing is that this equation tells me now the second term is called sometimes salient. Because of saliency present, this term is present. It is called reluctance power or torque. It is because salient x d x q are different, that is why you are getting this term. And this term, this power does not depend on excitation E f. No E f is there, V is terminal voltage, bus voltage. Therefore, it looks like, this point is very important, you must understand that a salient pole synchronous machine connected to bus may produce torque or power even when E f is 0. The E f is what? Field current of the synchronous machine. So, suppose field current with 0, this equation tells me that even steady state operating point, okay, it was running, you gradually make the field current of your synchronous machine down to 0, still a salient pole machine will produce a torque or power, and then the machine is said to be operating as a reluctance motor, because it will still operate at synchronous speed, but the level of power it can handle becomes less, because difference of x d and x q will decide that how much will be the maximum power. But nonetheless, what I am trying to stress upon is the fact that a salient pole machine, even with field current 0, can produce torque and power. It will still be running at synchronous speed, but the level of power will be reduced, no doubt, but it will be able to pump some power into the bus or take power from the bus as a motor as well. So, this expression is very important. Okay. One should memorize this. Of course, just not that you memorize just out of nothing, but this is worth remembering for solving problems or explaining many other things. That is, this term, there will be no effect on excitation of this term. So, a salient pole synchronous machine, then I know that how to draw the phasor diagram correctly, how to fix up the q axis, t axis, because I A is to be resolved into I d x q, I d and I q, and their effects are to be taken into account by two reactances x d x q. And then this is important, how do I find out the power. So, we started from the V I A star, and that is here from terminal voltage can be written as V d plus j v q, similarly I A can be written as I d plus I j q, and so on. Put the values of I A star, get rid of I d I q from the phasor diagram, and you can get the power delivered by the machine. I will leave as an exercise to you to find out the expression for the power after drawing the phasor diagram of a synchronous motor, and solve many problems. In the next time, I will take maximum another 3 lectures, where I will conclude and draw the phasor diagram of synchronous motor. But nonetheless, you on your own try, because in case of synchronous motor, you have to start from, it is better, that is what I do, that is translate the problem in terms of addition of vectors. It becomes easy. Draw first E f, I a, then E a plus I a r a plus j I d x d plus j I q x q will give you terminal voltage, and E f will be below phi. So, with this note I finish today, and we will take up in the next class some interesting informations about salient pole machines. Thank you.